Today I want to talk a little bit about the opportunities and challenges. And before I start with the opportunities, I'm sure a lot of you have heard about the Moore's law. And interestingly, Moore's law applies to AI technology as well. The reason is because as the advance in technology happens, right, everything is doubling. So whatever that we see today, um, all you think about AI, what you can do, we are surely underestimating its potential because every couple of years, right, the technology will double itself. And therefore, all the things that you may think of in the science fiction, they probably will be coming through to us, right, sooner rather than later. You can think back about the autonomous vehicle. Many years ago, nothing seems to be moving. And in the recent years, suddenly there's a boom of it. And the reason is because AI technology, particularly the image recognition, has become very, very powerful. And why is that important? The reason is because in the past, the AI technology cannot differentiate, say, for example, a fire hydrant or a small boy wearing a red shirt. And that's very important because if you cannot predict what you are seeing, obviously the autonomous vehicle will not work. If you see a fire hydrant, you know that it's not going to move, right? But a child wearing a red shirt is likely to dash out on the road. So that is the impact of computer vision, the impact of AI that we have today. So this is one of the example. A lot of people didn't realize that this is actually AI. And this is something that we often do and are often very frustrated. Whenever you want to fill up a form, you have what you call a CAPTCHA. So the CAPTCHA is actually what I call a reverse Turing test. Turing once thought of an idea, is a thought experiment, whether computer can be imitating a human and you can't guess who it is, whether it's a computer or it's an actual human being. But today, we have what we call a reverse Turing. It is not a human who's making the guess, but the computer is trying to understand, based on our behavior, whether we are human or not. And today, computers are better than humans in trying to determine whether the party on the other end is a computer or an actual human being. And that's how powerful computing is. And another example of machine learning and AI is what you see on your day-to-day, like for example, your GPS, your Google Map. And this kind of like data, right, can help us predict what route you can take best and also the corresponding time. All this require a lot of sophisticated machine learning to help us do the routing and also to let us like have an informed decision like how long it's going to take from your point A to point B. And this particular app also uses something called CoOp. So if you haven't understood what a CoOp is, let me explain a little bit. CoOp means that it takes data from everybody, aggregate it, and then display it back to you. So in my actual work, we use a lot of CoOp kind of like data. So example is your devices. Many people use different kind of devices. Like for example, you may have two mobile phones, one for your personal use and one for work. You may have a laptop, you may have an iPad. Some of you even have a laptop at home that is separated from your work device. So how do we know that all these devices are connected? And a lot of companies are using what we call data cooperation. So what they do is like they share information with one another. That means that if you log into one device and another device, we can determine that you are the same owner of these two devices. And what happened is like when the companies share the data, we have a better overall understanding of how the device are connected, and we can plot a device graph, and that will help us do a lot of like personalization and targeting better. But of course, this also have some sort of like data privacy issues. Later, I'm going to talk a little bit more about data privacy. So the large amount of data, right, drive the AI itself. So we have heard about many sources, like for example, your Google Assistant, your Siri, and all this, right, spying on you. Is it really true? Some people have done experiments. They say that by talking or by emailing people, right, on Gmail, and suddenly they start to see relevant ads, right? Although a lot of these big tech companies are saying that no, we do not spy on you. The algorithms may infer certain things, but they do not analyze individuals' conversation. But is that ethical or not? Or is it a better customer experience because whatever you are thinking of, like you want to go with your colleague for lunch, they recommend some lunch location. Is it an improvement of the customer experience, or is it intrusion of privacy? I'm not giving you answers, but this is something for you to think about, because sometimes like this AI can go beyond the intended function. So do you think it's ethical? This is also questionable. I'm not giving answer like I said earlier. It's just for you to think about the implication. So the areas of the concerns are basically, as I mentioned, privacy and surveillance, and also data have bias and discrimination. And so when we talk about bias and discrimination, it becomes very important because sometimes culturally we have inbuilt biases. So later I'm going to talk a little bit more about it. And finally, it's like human judgment itself. What can data do, and whether it's and some of the things that we can do are really not considered ethical. And later you're going to see examples of it. So this is an example of video surveillance. Uh, Video surveillance, right, can be used by insurers to harness a lot of data. So today, some insurers are really doing it. We have done projects, right, in other countries where we put in surveillance data. So what they do is like they incentivize the people, right, to actually put up a camera, and it's connected to the app. Or some of them are using other form of data, like for example, the we will collect data on the speed, on the movement, and all those. And these are very useful in terms of like determining the fault of the driver themselves. So we incentivize the people who wants to like give the insurance data. But of course, there are other form of like use of this data that could be a little bit unethical. So we talk about the Big Brother in China. They use this kind of surveillance data, right, to do facial recognition, and they also like see whether you're jailworking or not, you're doing anything that's anti-social or not. Is this the kind of life we want to lead? It's like 1984 all over again, right? So is this the kind of life that we want to live, or is it a better society because everybody knows that they are being monitored? One example of video surveillance technique is something that we did for customer overseas. We use it to prevent crimes. So basically, when people are thinking of shoplifting, they tend to like hover around. They tend to look left and right. So there's a telltale sign that the person is going to shoplift. So we use it to like predict whether a person is behaving suspiciously, and is linked to the intercom system, which would then play automated messages that say shoplifting is a crime. Yeah. And that itself deters quite a fair bit of shoplifting. So but is it but other than that, right, if we use the data itself, right, to identify people and start to ban people from coming to the store, is it considered ethical or not? Because if the person is being deterred, the crime has not taken place yet. So do we still treat the person as a criminal? That's a question to ask. Yeah. So from our conversation with our clients, we tell them that we should not collect this data itself because it intrudes into other areas that we may not consider ethical, and the law is very gray in this area. So we decided that it is mainly used for deterrence purposes. This is also another interesting project that we have done. Today, what happened is like a lot of these movers, they allow you to take a picture of your house, take a picture of things that you want to move, and then send it to them. And somebody is going to like take a look at the picture and give you a quote. Like for example, oh, you need to move a bed, you need to move some painting, some furniture. They are going to use it to estimate how many boxes you need and what's the size of the transportation vehicle and how many vehicles you need to actually give a quote. So the company approached us is because they are bottleneck. They are not sufficient, not enough salespeople to actually give the quote. And sometimes the customer, because they waited too long to get a quote, they may go to competitors. So what they wanted us to do is actually train up an algorithm based on all the previous pictures and the quotation that's given, right, to sort of like give a sort of like a predictive quote. And after training, we realized that the computer can actually give a very accurate quote. In fact, better than humans, because sometimes humans are based on variations. Maybe you're in a good mood today, you will give a lower quote. You're in a bad mood today, you'll say that this seems difficult, and you give a higher quote. So computer can take out the emotions and give a better quote. But what is scary about it is when we collected all this data itself to do the training, we just put it into some off-the-shelf solution from one of the crowd solution provider. We realized that we can classify the people into many groups, and it actually gave us unintended kind of information. Like for example, we are able to tell whether the person is a high net worth. We can tell the interest in the person by the belongings in the house, like whether they are sporty people, they like arts, they have branded items. So these are something that what we call unintended consequences of collecting data. Now we start to have a wealth of information, like brand preferences, lifestyle preferences, or even sort of like a proxy for their net worth. And bedrooms and those are your houses is actually a very private space. So do you want things in your house to be exposed to advertisers? That's also a question that we need to think about. Is it ethical for them to use such information? And potentially some of these people who have information about your belongings at home can sell this data to an advertiser to profile you. So this is also a question whether this is an intrusion of privacy or not, whether the data given right will allow people to profile us and target us more easily. On the flip side, like I mentioned, everything has this, when people want to use data, right, we always think about them intruding on the privacy. But on the flip side, if it's done more ethically, can we have more targeted advertisement so that we don't see things like junk information that we don't want? Could it be an improvement on the customer experience? How far does it go before we feel that the line is crossed? This is also something that I want everybody to think about. So we also talk about this self-driving cars, and although we don't do self-driving vehicles, we did because of our work in the ethics. So we do collaborate with a lot of like government agencies on what is ethics. And one interesting thing is there's no framework to to define what is being ethical. And that is something that is troubling a lot of people. Say, for example, an accident were to happen, who should the self-driving vehicles?
我发的那个东西嘛。
Sorry, I thought that was a question.
不
Okay.
仅
So let me continue. So different areas of the world have a different idea of what is ethical. Like for example, if you go to the US, they always say that okay, we should save the women, save the children because they are considered weaker. And so if you go to the Middle East, maybe the thinking will be very different. They are very male dominated society. So if you go to different places, right, the idea of who to save is very different. And who should decide how should all these vehicle behave? The answer is we don't know, and nobody wants to lead this kind of discussion. And one of the reasons why people do not want to lead this kind of discussion is also for fear of repercussion. If we decide that we should save the women and the children, and then a male died from the accident, somebody can actually sue the government or sue the manufacturer for liability because the decision is made for them. And maybe the person is a very important person, high net worth person, and there are also legal things to consider because they say this person's life is very important. Why do you choose maybe a old person over him? So these are areas where it is still debatable, but somehow or rather people don't want to take a stand simply because for fear of these are potential legal liabilities. So the other thing is like moving gear, right, to talk about some of our work. I wanted to like check a little bit on our understanding of basic math. So if a test has a false positive rate of 1%, that means that this breath analyzer, imagine every 100% who take the test that is not drunk, you have a false positive. One person show up drunk. And if the person is drunk, right, this test is foolproof. 100% you will show up positive. So if you have a person that actually taken the test and it turned out to be positive, how sure are you that the person is really drunk? Maybe you can type in the chat. Let's see how many people get the answer correctly. Okay, let me see. Okay, the answer is we don't know. The reason is because we don't know the prevailing rate of the people who are drunk. So that is very important. Later, I'll tell you why is it very important. So right now, for this question itself, right, is very rhetorical. There's no answer because even the best mathematician will not be able to give you the answer. So now I give you the prevailing rate. 1 in 1,000% is really drunk. So what's the probability now? If somebody tested drunk, what's the probability that the person is actually drunk? Okay, in the interest of time, I move on. We got a very good answer there. Yeah. So imagine you have 1,000 people, they are tested. The false positive will be almost 10. It's actually 9.99. Okay, so it's about 10. And you have one true positive. So 11% will be tested positive, right, out of 1,000 people. So the actual number of people that is actually drunk, right, is only 1 out of 11. Yeah, so that is very, very low. This is very important because most of you have not thought about this, right? And unless somebody posts it to you as an academic question. And unfortunately, most of our clients, right, are not trained engineers. They are not trained in math. So we have to educate them on the reliability of AI, reliability of machine learning. So this is some of the struggle that we have at work, because we need to explain what does the false positive mean, and when there's a false positive, what's the implication? Obviously, when the number are very, very small, the false positive tend to be very, very real. But if you're talking about large number, like for example, this breath analyzer uh, test, if the false positive rate, right, is 1%, right, if you test thousands of people per night, you are going to have a lot of people who are showing up as positive. If the police is using it to convict, then a lot of people will unfortunately be convicted for no reason. Yeah. So luckily for us, the breath analyzer test is more accurate than that. So we are safe. But this have a lot of implications. I'll tell you what the implications are. Yeah. So this is an actual project itself. For those of you who are very much into data science, you realize that this is a Markov chain text generator. So the what it does is that it can train writing style of people. That means that I give you a lot of text, right, on your how you write your words. Everybody have a different writing style. So and talking style is exactly the same. So what happens is like whenever you put in a word, right, it can predict what is the next word, and that is also how your iPhone, your Android phone, and all this predict your next word that you're going to do in the predictive text. So if you use it more than enough, you'll start to realize that you start to guess the next word that you are trying to use, right, very accurately, because it has been trained to understand your writing style itself. So likewise, we are also able to tell whether somebody's writing style differs from their previous work. So this is actually a university. What we did is like we have all the online assignments that is supervised of the students, right, been input into the training model, and then we are able to tell whether the actual assignment that's unsupervised and graded are done by the student or not. So we will check for the writing style itself. But as I mentioned, there's also what you call false positive, which means that the people who are being flagged out as like this is not their own work, doesn't mean that it's really not their work. So going back to the previous example, they are, if the number of students tested is sufficient, right, there are always cases of false positive being flagged out. So the way to overcome this constraint is to tell a lecturer you have to go and interview the students for the understanding, so that we sort of like try to, it's a diagnosis, just like a doctor, right? If you go for a diagnostic test, there's, for example, your cancer marker is high, doesn't mean that you have cancer. So you have to perform a deeper analysis to see whether it is real or it's a false positive. Likewise, for this case, right, we also try to see whether there's a false positive or not by the actual interview itself. Next, this is not obviously not a work that we have done, but then I just want to show it to tell you that there are opportunities everywhere. Sometimes we just have to be a little bit more creative. So what this student did is like we downloaded thousands of images of of this skin cancer and input into I'll say it's an open source algorithm developed by MIT. And so a person who knows very little about coding, simply because he has access to a good algorithm provided by university, and he have access to internet where he can download lots of pictures and input it as a training data. And the app is so good at predicting cancer that is more accurate than a doctor. So now even some doctors are using the app, right, to confirm their diagnosis. So this shows that the opportunity is everywhere, as long as you know how to link one and one together and create your own killer apps. So I want to share some story about our work. The data science projects, right, they are not very well defined. So business do not come to you and say that, oh, I have a data problem for you to solve. Business have business problems. They have a KPI problem. So the projects are always not well defined as this is a data problem itself. So this example is from one of our clients, an insurance company. They came to us and tell us that the sales among their existing customer is dropping. So what can you do about it? And obviously they do not just look for us, right, as a potential vendor. They look for many other vendors as well. And some people do not see it as a data problem. Some people see it as a training problem. So they have a lot of like sales training for them to be more articulate so that they can sell more products, right, to their existing customer. And so if you have a toolkit in your box that is a data science, then it becomes another consideration for you to solve your problem. Like if the only tool in your box, right, is a hammer, every problem will look like a nail, right? So and it's very important for us to know as many things as possible so that we have many toolkits in our box to use, right, when the occasion calls for it. So how do we uncover this as a potential data problem? It's because we did a lot of interviews, right, with the salespeople, and we realized that the very experienced salespeople, right, have an intuition on whether a person is going to buy or not. So we asked them, can you qualify your intuition? Most of the time, right, they won't be able to say it, but say, oh, I think the person is going to buy because they reach this age already. From experience, people reach this age or buy, or this person just have a kid. It's like, or this person recently made a claim, so he got money in the bank. So these are things that are data sets, and more experienced people, they are using their brain as a data processor. So the brain is actually a very good machine learning tool. It's just that we are unable to explain it. So it's just like a black box. But for data scientists, we know that they are using certain data points, right, to sort of like predict. So when we started using this, right, to do a prediction on the propensity to buy, the more experienced agents actually tell us that actually it's very, very true. It's like it's sort of like aligned with what they are thinking. But for the younger and less experienced agent, this is like magic. Suddenly they have hotter than normal leads. So this is something that helps them improve on the sales. Okay, I want to close it off by saying that with great power comes great responsibility, and therefore with more power in data and these are AI, right, we have a responsibility, right, in the society, right, to make us more human. That means a more fair and a more just society, so that we can do what makes us human and what we truly stand for. Okay, thank you very much.